Well, welcome back to the Warehouse 14 bench, everyone. It's been a while since I've made a video, but I ran across this item. Actually, a good friend of mine brought it to me. He said he bought it at a garage sale and didn't give too much money for it, but he wasn't sure it worked or not, and thankfully he did not plug it in to see if it was going to work. But what we have here is a Stewart Warner AM radio with a shortwave band on it. And thankfully, my friend did not plug it in to see if it was going to work. So it is a cold project here. We don't know if it's going to work or not, but it is missing some things on the cabinet. As I look at it here, it's missing this piece here. It should go over here, and it's gone. And some of the veneer is in pretty rough shape here. But what we're going to do is test it and see if it's worth fixing and restoring or not. But it's a pretty nice item. As I say, it's a Stewart Warner Model 9000. Looks like a B on that. It's AC/DC, rated at 30 watts. And I noticed that the tube complement inside looks like it has 6 tubes, so it's a little bit better than the old All-American 5. I would call it an All-American 6 in this case. Yeah, hopefully we can test it and see if we can get it going. I think before we do anything, I'm going to remove the chassis from the cabinet and see, give it a good visual inspection, and then see if it's got anything missing or broken or obviously bad before I even plug it into the current limiter. And we'll go from there. So let me get it out of the chassis and I'll be right back. Okay, I've got the knobs off the front. As you can see, I also have the 2 screws out of the bottom, and I noticed on the bottom there is a nice piece of paper here that has the model number. It is a B model, 9000, and as I said, I did the research on it, and it was built in 1946 by the Stewart Warner Company, who, as you know, still to this day makes some pretty nice automotive gauges as well. So that's relatively intact. Let's take a look here. It has some pretty nice tube complement and has a rather unique loop antenna on it. I was kind of surprised that that was a loop antenna. I've never seen one like that before. It's usually they're pasted onto the back of a piece of masonite type material, but this one really looks in pretty good shape. And I think we'll start, like I said, we've got the hardware loose from the front and the 2 screws out of the bottom, so let's just take these wires off. And if you run across one like this, you'll probably want to closely mark these wires, which I already did. I have a schematic for this, and that has the color coding of the wires, but over the last 75 years, they've kind of faded in color and maybe even changed color. So you'll want to mark those down well somewhere before you take them loose. And we'll get them off of here. And there's one more in the back here. Looks like it has an isolated loop antenna, so you could put a external antenna on it and have it isolated from the chassis. So, okay, we've got all those loose, so let's just pull this out. There we are. And we'll set the cabinet aside. Yeah, that looks pretty nice. Like I say, the first thing you want to do is give it a good visual inspection to make sure nothing's broken on it. Obviously broken. All the tubes are in place and hopefully in the right sockets. Take it over and see what the bottom looks like on this. Get a little light on it here. Okay. Wow, this is amazing. It looks like it's pretty original. I don't see any evidence that anything's been replaced on it. At least not in the last 50 years, anyway. These are the old waxy capacitors, which we're going to do a restore on this. We'll have to go. And I don't see any evidence of any critters in here, like bed bugs and things like that. So I think we're safe to keep it here in the warehouse for a while. Let's go ahead and fire this thing up. We'll put it on the current limiter. Actually, before we do that, we can make a couple of quick tests. For those of you who don't have a current limiting device. Well, that looks like we're going to have to change that cord out. That's not real safe, but let's go ahead and turn the power switch on over here. And we're just going to do a quick measurement, see if we've got any continuity through the power cord. And make sure that works. All right, and we're just going to take a measurement across the power cord here and see if we got anything that's... And wow, that is open. So either we have a bad cord, a bad switch, or a tube that has a filaments burned out. And go over here. I will just bypass the power switch here. And see if the meter comes alive. And it does not. So whatever's open in this certainly isn't the power switch. Well, our next step on this is to go in and take a look at the tubes. And I've got a suspicion that's probably a filament on the tubes. And here I have a pretty good schematic for this radio. And as you can see here, power should come through the plug and through the switch and then through all 7 tube filaments and then back out. That should be a pretty easy circuit to troubleshoot. I kind of like these type thing when they're just totally dead. They're usually pretty easy to figure out what's going on. So I'm going to go ahead and pull these tubes, and I'm going to just quickly test the filaments. Later, if I figure out there's one tube that's bad and have a replacement, I'll go ahead and throw them on the tube tester just to make sure I know what our starting point is going to be on this. But yeah, let me get that out, and we'll be right back. After testing a couple of tubes, I finally decided that it looks like the rectifier tube has an open filament connection in it. Now this tube's a little bit different, and I probably should have tested it first off, because that's usually the tube that goes out, because it's right close to the filter capacitors. And sometimes when you get a shorted filter capacitor, it'll wipe out the filament if it's, or the cathode bonding strap. But if you look on the 35Z5 right here, we can see that this actually has 3 connections to the filament. And right here we have pins 2, 3, and 7. And the reason why it's center tapped like that is because up here on the pilot light, it runs off of half of the filament connection on the rectifier tube. And as you can see there, that's where they put the panel light. And so let's just see, as I said, it's pins 2, 3, and 7, and counting from the keyway here. If you can look real close here, we'll go clockwise from the keyway, 1, 2, and here's pin 3. And as you can see on the meter here, we have 8.4 ohms. Now let's go over to pin 7. So it's an 8-pin tube, so we'll count counterclockwise from the keyway. So this would be pin 8 and pin 7. I'll get my hand out of the way here. And as you can see, it's an open filament. So that's probably what's holding us up here. So let me dig around in my tube collection, and we'll see if we can find a 35Z7. That's a pretty common tube, so I don't think we'll have any trouble finding that anywhere. So okay, look what I found. A nice 35Z5 GT, just like the old one. A little different brand, it's a Delco, but I think we'll give that a try. We'll just put him in the socket there. Okay, and I'm going to see what our resistance from the power cord looks like now. And here we go. Okay, looks like we got some activity here. It's like about 115 ohms, so I think that would be about right. So I think something should happen now when we plug this back into the current limiting device, and we'll bring it up slowly just in case something badly shorted in it, or the filter capacitor decides it wants to give up about halfway through the test. So we'll get ready for that. One thing I want to mention about these rectifier tubes before we get into our final segment here is that on these 35Z5 rectifiers, you'll notice that there are 2 pins, actually 3 pins for the filament. And usually on a 8-pin octal type tube, pins 2 and 7 are your primary filament pins. But you'll notice on the 35Z5 there is a center tap on the filament here, and that goes to pin 3. Now, the reason why they center tap that is because if you'll take a look at the schematic, and this applies to just about all non-transformered, All-American 5, All-American 6 radios, is that on the rectifier tube, they use the center tap as part of the circuit for the panel lamp. And that way they can light up a panel lamp and save a little parts count on the whole radio. But I want to show you something that's interesting about this, is if we take a measurement From pin 3, as I said, is the filament. 1, 2, 3. That'll be the center of the filament. And if we go to pin 2, you'll notice that the resistance is 7 ohms. Now, if we go from the center tap to pin 7, the resistance is way up there around 26 ohms. So it's quite an imbalance there. And as I said before, the reason they do that is so they can light the panel lamp on the radio, which is right up here. Let me reposition the camera just slightly. It's right there. Now, when they do that, they'll tap off that one that has the, I believe, the most resistance in it. And so this will balance out, that panel lamp will balance out the filament. Now, unfortunately, using this type of circuit in a radio, if that panel lamp burns out, you will have an imbalance in the filament, and it will shorten the life of that rectifier tube. And that's one reason why usually if there's a problem in a radio with a tube filament, it's probably the rectifier tube. Now, you can still run the radio with the panel lamp burned out, but you'll want to replace that so you don't shorten the life of the tube. Now let's go on to the next subject. As I was telling you earlier about measuring across the power cord pins to see if you have any type of short circuit in the radio. And you can do that, of course. And this will, as I said earlier, will give you a good indication of the circuitry inside the chassis, whether we're looking at something that's, let me turn this on here to make sure it's all working. Yeah, it's kind of intermittent here on this. We probably need to replace the power cord. Anyway, we do have continuity through there. Yeah, you can see that this thing really needs to be changed out. But you do have continuity through there, and that kind of gives us an overall idea of whether the filament string is intact. And that's about all it does, because if we have a problem with a filter capacitor, and believe you me, in an 80-year-old radio like this, I can almost guarantee you this capacitor is either very leaky or shorted or open. One of the three. And you won't know that until by using this test through the power cord, because until this rectifier tube begins conducting, it won't have a load on it. And if that capacitor is shorted, it won't show up until this rectifier tube begins conducting. Now the capacitors are up here, right here. There's two of them. They're 40 microfarad. And I think what you really want to do before you light this thing up or do anything with it is to go in there and measure the resistance across there to make sure they're not shorted out. Because as soon as that rectifier tube begins conducting and those capacitors are shorted, it's going to draw an immense amount of current and probably take out this 35Z5 rectifier tube. It'll blow the binding strap right off the cathode on that. And so we're going to do that right now just to make a quick check. And it's not a big deal. It's easy to do. And I am going to zoom in on the pins on the rectifier down here, which are right here. Where my finger is. And I know it's very hard to see in this kind of lighting, but we'll do our best at it. But what you'll want to do first before connecting your meter across that is discharge those, just in case somebody had turned this on and those capacitors are fully charged, or even have a, say, an 80-volt charge on it. You'll want to discharge those either with a alligator clip or a 100-ohm resistor, which I have here. That's my kind of go-to resistor to discharge those. And so I'll just lay it across there for a few seconds and across the pins there. And that will discharge it. The reason I do that is not so much for my safety, which is a good thing, is that I don't want to blow up my expensive VTV or voltmeter here. So what we'll do now is we will go from ground and across one of the 40 microfarad capacitors, and see we're up in the 2 megohm range, so that's good. And let's go to the other one. It should be down here. And that's showing 1.7 million ohms. So they're not shorted. That's a good thing. And since this meter has a capacitance tester on it, I'm going to change the function to capacitance. And just out of curiosity, I'm just going to see what the capacitance reads on this. It should be 40 microfarads, but as you see here, it's 12. So it's really not in good shape. And that one's 15, so that's not good. But it's not going to damage anything if we light it up. At least if we light it up and it blows up after about a minute or two of running, which capacitors have a tendency to do that. Apply voltage to it and suddenly they say, hey, something's coming alive here. And what happens is they'll get really leaky or develop an instant short circuit. And that's why we always want to use a dim bulb current limiter. And let me reposition the camera here. And we will go ahead and get this thing set up so it'll receive a signal. So I'm going to get the radio wired in with the antenna and everything. So if it does happen to work, we'll at least maybe receive a signal. All right, I repositioned the camera so we can see the radio a little better, and I turned the lights down so if anything starts glowing here, we'll be able to see it on camera a little bit better. I'm about to plug this into the dim bulb current limiter, which is up here on the wall. And I've got a 60-watt clear bulb right here in the dim bulb current limiter. Here's the variac. We're going to bring it up real slow so we won't fry anything. And if something does short out, the bulb will limit the current flow on it. And here's a voltmeter. I hope you can see that on camera. I think so. And I've got the radio turned on, volume about halfway up. The antenna plugged back in, the loop antenna. So let's go ahead and turn on the variac. And we'll start bringing this up real slow. And I'm going to probably bring it up to about 50 volts for just a few seconds here. And maybe we'll see something come alive. Yeah, I think the looks like the panel light is coming alive here. I don't know if you can see that or not, but it's right up here. Got a real dim glow to it, so let's bring it up about 10 more volts. I don't see anything on the tubes coming in yet, but sometimes they take about 70 to 80 volts before they start lighting up the cathodes on them. Bring her up a few more here. According to my meter, we're at it's like about 50 volts, 60 volts maybe. Oh, I think I hear something. There it is. Okay, I do hear something. Hear a buzz anyway. That's probably because the filter capacitors are shot. Crank it up a little higher. Okay, right now we're at about 80 volts AC. I think I hear a station in there. And our dim bulb isn't lit up at all yet, so I think we're safe to go on up. Let's take her up to about 100 volts. Okay, we're right at 100 volts on the AC, and I do hear a station in there. He's talking. Panel lights lighting up, and we've got a little bit of activity on the current limiter up here. You can see it's starting to glow just slightly. That a little bit, which is normal because it's got to have some load. Let's take her up to the full 120 volts AC here. Okay, we're at 120 volts AC. Definitely a station in there. And lots of hum. There's another station. I can hear it a little bit. Well, I think this receiver's working, at least on the AM band it is. And it's not drawing any excessive current here or on the amp meter. I think we'll just go ahead and kill this for now. And looks like we have a good radio that we can start working on. I'll have to get a hold of my buddy, see if he really wants to put any money into it, because it's going to need recapped, because they are all 80-year-old capacitors in it, and I don't want to send it out to him that way. And need a new power cord, of course, and just some good cleaning and tuning up. So let me get with him, and we'll go ahead and start restoring this to his specifications. And I will come back later, probably with part 2 on this, just to see how it turns out. If I don't come back with part 2, then you'll know the guy didn't want to put any money into restoring this. So anyway, I think we've got a good radio here. And we can see that even though it's quite dirty, it does work. And so we'll just come back later and with part 2, hopefully. Thanks for tuning in, everybody. Hope you got something out of this. Learned a little bit about All-American 5s and All-American 6 radios and rectifier tubes and the like, and a few troubleshooting techniques. You don't really need a lot of equipment to troubleshoot some of these. Good Volt-Ohm-Meter. If we come back with it, I will show you how to align it with a minimum of equipment, hopefully. So thanks again for watching. We'll catch you in the next video.